でその方もなんで私に友達リクエストしてきたのか忘れちゃったわとかとにかくリクエストが来て、私も一応承認するときには相手のプロフィールとか見たりしますので、見させていただいて、こんな学校の先生でね、大学まで高齢の方で来たんだってすごい嬉しくって、友達承認をしたのがもう今から2、3年前なんですね。でそれからフェイスブック上でいつも私が書いてることにアップすることにコメントをくださる方で、私もコメント本当大変申し訳ないんですけども、たくさんの方がコメントとかくださるのでちゃんと読んではいますけども、いちいち返すっていうとすごく不公平になってしまう時がたまにあるので、返さないことを結構それは意識的にしてることもあるんですね。でもやっぱり気になった時とか、これは返した時がいいなっていう時は返したりするんですが、その方にはいつも返してたんですね。そしたら一度お会いしましょうっていうことを言って、で薫さんに会いに頑張って東京に行きたいっていうふうに言ってくださって、で私もじゃあ私のフィールドワークでそういうインタビューやってますから、その70年のキャリア人生もずっと大学を出られて学校の先生をやってましたから、で今は介護施設に入ってるんですけども、そのことも含めてお話を伺いたいっていうので、去年の11月息子さんのお嫁さんに連れられて東京にいらっしゃって、で東京ではその方のいとこの息子さんがいつもアテンドしてくれるっていうので、その方と合流して私がそこに入って、4人ですね、4人でその女性のインタビューをさせていただいたんですね。で実はご主人がその方よりも年が2つぐらい上なんですけども、車椅子の生活になっていて、でずっと息子さんのところでお世話になってたんですけども、やっぱり体が男性ですから大きいので、やっぱり車椅子で生活しても降りてくるとたまにパタンと倒れてしまう。
So going really overlapping. The first how to identify rocks and the geology side of what astronauts need to know, as well as a few other things. And some of the things that this team has just recently finished, they did a global lunar landing site database that is now open and available for the entire community. So these teams are creating materials that are available not just for the teams themselves, but to the entire science and exploration community. Okay, so another thing that we do at the Virtual Institute that I really like a lot is we build and share facilities. And this first picture that we have here is about the dust accelerator that I mentioned at the University of Colorado, and that was up and running actually during the Lunar Science Institute again, because again Mihai Harani was one of the principal investigators who led a team under the Lunar Science Institute that is now part of CERDI. And at Brown University there's something called ReLab. This is a spectroscopy lab where they look at samples and help people analyze and understand what their field samples are made of, and the new components that they make as well. And at Brown University they've also developed something that is a 3D immersive environment, which is something that I think the Google folks would be especially interested in, so that you feel like you're there and you look around in all directions and it's just like you're really there. This was modeled after the what we call the kekkai, which are the UC Davis. Maybe some of you are familiar with that. But they have the same kind of facility now at Brown University. And at Ames, we have a couple of facilities that we share as well. There's a regolith test bed where we have 8 tons of simulant of lunar material, and we have little rovers that run around in this yard. I use it with students remotely. They can be across the world, and they can operate the rover, and we built in little lessons where they can go up and try and identify the difference between a meteorite and a rock and take pictures of it, that sort of thing. There are scientific uses for the test bed as well. And at Stony Brook University, there is a vibrational spectroscopy lab. And this is, again, something where people would bring their samples to it and try and understand, or something that was built or created, and try to understand more about how it would interact with or be interacted on by some sort of process. Also what it's made out of. Okay, another part I wanted to stress is the serving team collaborations that we have across the team lines. And so just a couple of examples. This first one came about in the very first experience where we brought the principal investigators together to meet for the first time. And over this 2-day period where they met face-to-face, we were at NASA Ames, we asked them to please come up with a list of areas where they thought their area could cross over and they could find a collaboration with one of the other teams. We had each of the teams give a little synopsis of what their proposal was. Now keep in mind, these were teams that were competitors just moments ago, and now we're asking them to share everything. Share your data, share your processes, tell us what you're going to do, and look for ways, trust each other, look for ways to work together. And they did it instantly. And one of the ideas that came out of it was to have this sample repository at the Natural History Museum, where any team that collects any kind of field sample or had a sample that they made could bring it together and put it in one place, so that if you wanted to do some sort of process on it, you could know that you were using the same rock. 2 different teams doing 2 different processes on the same sample is a lot better than using 2 entirely different samples that you just happen to think are the same rock, the same material. And this one ran into just a little bit of a hiccup because it turns out the Natural History Museum does not take samples that are found on Earth, but they only take samples that you create. So we're looking for another home for the actual field samples at this point. But this was a great idea, and they started putting all their materials together right away. I was just really pleased to do that, to see that happen. And another one is the asteroid modeling. So the dynamics that we talked about with the early solar system and what happened to it when you had all this bombardment in the early days, when you couple that to geochemical studies of the rocks that people have found either from meteorite samples that have come off planet, from someplace else, or the lunar samples that came back from the moon, you couple that together with the dynamics and you can learn an awful lot about what happened when. And what we call the late heavy bombardment period that affected both the Earth and the Moon system is one of those times that we'd really like to understand better, because it looks very, very likely that the Moon formed out of a giant Mars-sized body